Hello everybody, this is Mrs. Snook with section 6.4 notes. We're going to do vectors and dot products. Our objective is to find the dot product of two vectors and use the properties of the dot product. We're going to find the angle between two vectors and determine if those two vectors are orthogonal. We're going to write vectors as the sum of vector components, and we're going to solve a real-world problem using vectors. First off, the definition of dot product. So dot product is a way to multiply two vectors together. And what you do is you take the horizontal components, multiply those together, and then you add them to the vertical components, multiply those together. So all you're going to do is multiply those components and then add them together. So let's do a couple examples of this. First one, we have a vector with components 4, 5, dot the vector with components 2, 3. So I'm going to take the 4 and the 2, multiply them together, and then I'm going to take the 5 and the 3, multiply them together, add those products, so I get 8 plus 15, or 23. Now your answer when you calculate a dot product is going to just be a scalar. It's going to be a number, not a vector. Now let's look at D. You have U is negative 2i minus 2j. That's also a component form. And V is minus 3i. And you can think of that as a 0j. So when I do the dot product there, I'm going to take the negative 2 and the negative 3 on the i's, add those, multiply them and add. And then I have the negative 2 and the 0. Now that 0 times negative 2, that goes away, so my answer is going to be 6. So you can do the dot product if we have it in component form or we have it times the unit vectors. Next thing we're going to do is we're going to use some properties of dot products. First one, we have u dot v times w. Now remember, when I dot u and v, I'm going to get a scalar, and then I can just multiply that by the vector w. So do what's in parentheses first. So I'm going to do my dot product first. So negative 1 times 2 plus a 3 times a negative 4. So I get a negative 2 minus 12. I get a negative 14. That's my dot product. And now I just have to multiply that times times w. So negative 14 multiplied by vector w, I get a negative 14 times a 1 and a negative 2. Just distribute. So my components now are negative 14 and a positive 28. Next one, I'm going to do a dot product of 2 times vector v. So I'm going to take u, which is a negative 1, 3, and I'm going to dot that with 2 times vector v. Vector v is a 2, negative 4, so go ahead and double those. And now I'm going to dot. So negative 1 times 4 plus a 3 times a negative 8. I get a negative 4 minus 24, or negative 28. So this time I have a scalar as my answer. My last one is to find the magnitude of vector u, and we're going to use dot products to do that. So check this out. If I do a u dot u, that's going to give me a negative 1 times negative 1, and I'm going to add that to a 3 times a 3. But guess what? That's what you would do to find the magnitude, except you would square root it. So if I square root my dot product, I get the magnitude. So my magnitude of vector u is going to be the square root of u dot u. So that's going to be the square root of 1 plus 9, which gives me square root of 10. So magnitude, oh, I already wrote that down. Just want to emphasize that our magnitude of any vector is just going to be the square root of the dot product with itself. Now with dot products and magnitudes, we have a nice way to find the angle between two vectors. And what we're going to do is we're going to take our two vectors, in this case it's u and v, dot product them, and then divide by the magnitude of u times the magnitude of v. And when you do that, you're going to get the cosine of your angle. So let's go ahead and do an example like this. I'm going to find the angle between vector u, which is 4, 3, and vector v, which is 3, 5. And I'm just going to use the formula. So cosine of theta is going to be u dot v. So I'm doing my dot product, and then I'm going to divide by the magnitudes. Easy way to do this is just find each piece and then plug it in. So first is going to be the dot product of u dot v. So that's going to be a 4 times 3 plus 3 times 5. I'm going to get 27. Now let's get the magnitude of u. I'm going to get the square root of the dot product of u dot u. So 4 times 4 plus 3 times 3. I'm going to get square root of 25, and that equals 5. Now let's get the dot product of v dot v. I'm going to square root that. So square root of 3 times 3 plus 5 times 5. I get the square root of 9 plus 25, so square root of 34. All right, now let's plug everything in. So my cosine of theta is going to equal 27 over 5 times the square root of 34. Just punch that into your calculator, and cosine theta equals 7 divided by 5, and then divide that by the square root of 34. I got 0.9261. Now I'm just going to hit my inverse cosine button of my answer that I got. I get 22.16 degrees. I'm going to round that to 1 decimal point, so 22.2 degrees. The last idea we're going to do is we're going to find work. Now that is a concept in physics and engineering, and the work that you do is defined as the force you apply dotted with the direction that you're applying that force. So for here we have a barn door, and to close that barn's door, a person is using a rope, and they're applying a constant force of 50 pounds at a constant angle of 60 degrees. So our force vector is 50 pounds at 60 degrees. And then the d vector, that we're told is 12 feet, and it's going along the direction that the door closes. So that's a 12, and it's going horizontally, so that's a 12i. So what I need to do is convert that force vector into the component forms. And so here's an easy equation for doing that. So my force vector, it's going to be the magnitude of the force vector times the cosine of theta in the I direction plus the magnitude of your force times the sine of theta in the j direction. So magnitude is 50 pounds times the cosine of 60 in the I direction plus my 50 pounds times the sine of 60 in the j direction. So 50 times cosine 60, I get 25i, plus now 50 times sine of 60, I get 43.3j. So here we have converted our f into component form, and now I'm just going to dot it with the d. So f dot d is going to be 25 times the 12, because those are both in the I direction. I don't have a j for the distance, so I'm going to do 43.3 times 0, because I don't have a j. And my answer for this work, the f dot d, is going to be 300, and get this, it's going to be 300 foot-pounds. Foot-pounds is kind of an obscure unit. If you're taking physics, you might do more in newtons or joules. All right, that's it for today's video. Thank you for watching, and have yourselves a great day.